For connected graph gamma, the diameter d is the maximal distance in graph. For a vertex x, we denote gamma sub ix is the set of vertices which have distance I from x. For example, we set a vertex x, then x itself is gamma 0x, and these three vertices gamma 1x, and these are gamma 2x, and this vertex is gamma 3x. And we write gamma x instead of gamma 1x, and the balance of a vertex x is the cardinality of gamma x. If a graph gamma is regular graph, a graph gamma is called regular graph with balance k if for any vertex x, the cardinality of gamma x is k. And a graph gamma is called distance regular graph if for any two vertices with distance I satisfying the following. If I fix a vertex x, then we can divide the vertex set like this. Then the distance between x and y is I. That means y belongs to gamma ix. Then y have to ci neighbors in gamma I minus 1x and ai neighbors in gamma ix, and bi neighbors in gamma I plus 1x. Then we call the graph. Then the graph is called distance regular graph. And also we call the numbers ai, bi, ci, ai, bi as intersection numbers, and the array of intersection numbers like this: b0, b1, bd minus 1, c1, c2, cd is called intersection array. For a distance regular graph gamma and a vertex x, we denote ki is the cardinality of gamma ix. And a graph is called bipartite if the vertex set can be partitioned into two parts, v1 and v2, such that every edge has one end in v1 and one in v2. For a distance regular graph gamma, if gamma is bipartite if and only if ai is 0. A distance regular graph with this intersection array, the graph is called Taylor graph. That means the B1 is equal to C2 and B2 is 1. For example, the given graph is distance regular graph with intersection array 3, 2, 1, 1, 2, 3. So this is a Taylor graph, and if we divide vertex set like this, black 1 and red 1, then this graph is also bipartite. The adjacency matrix A of graph gamma is the matrix indexed, the rows and columns are indexed by vertices, and the A, X, Y is 1 if A is addition to Y and 0 otherwise. And an eigenvalue of gamma is that of adjacency matrix of gamma. And if gamma is a distance regular graph, then gamma has exactly d plus 1 distinct eigenvalues k, theta 1, and theta d. This theorem is very useful. We usually call interlacing. Let A be a real symmetric n by n matrix, and let B be a principal submatrix of A with order n by n. Then for i's 1 to n, theta I of B is at most theta I of A, and least theta n minus m plus I of A. The local graph delta x over vertex x is the subgraph induced by gamma x. If the graph is called complete if any two vertices are adjacent, and clique is a subgraph that is complete. And non-complete graph gamma is called Tolliver if for any two vertices xy at distance 2, the gamma, the induced subgraph of gamma x intersection gamma y is a clique of size c. For example, the isocosahedron have intersection array 5 to 1, 1 to 5. So this is a Taylor graph, and if I take a vertex x, then the local graph of x is pentagon, and if I take any vertex y from y, distance 2 from x, then the local graph of y is also pentagon, and the intersection of them is complete graph, so this is also Taylor graph. This is the known result. Let gamma be a distance regular graph with diameter and least 4 and balance k, then C2 is at most half k and equality if and only gamma is a polygon or Hadamard graph, where Hadamard graph has an intersection array like this, and C2 is at most A2 if A2 is positive. But such a result is not true for diameter 3. For example, n-crown graph is a distance regular graph with the intersection array n-1, n-2, 1, 1, n-2, n-1. If n is small, the shape is like this. And if n is at least 4, then here C2 is bigger than half k. So this is an exception of first condition. And the Gaussian graph have intersection array 27, 10, 1, 1, 10, 27. With the same vertex set, if I connect two vertices, if their distance is 2, that means the distance 2 graph has intersection array 27, 16, 1, 1, 16, 27. Then here C2 is 16 and A2 is 10. So this is an exception of second condition. And also for this known result, the only exceptions are the only known exceptions are Taylor graph. So we are finding feasible condition of Taylor graphs. From now on, I will introduce our results. Let gamma be a distance regular graph with diameter 3. If P3, 2, 2 is 0, then gamma is Taylor graph or bipartite, where P3, 2, 2 is the cardinality of gamma 2x intersection gamma 2y, and the distance between xy is 3. P3, 2, 2 is C3 times A2 plus A3 minus A1 over C2 is 0. That implies A2 plus A3 is A1. In first case, A1 is 0, then A2 and A3 also 0. That means the graph is bipartite. And if A1 is positive, we will use the following proposition. Let gamma be a distance regular graph with diameter d and assume A1 is positive. Then AI plus 1 is at least A1 plus 1. If I is positive, I is bigger than 0 and smaller than d minus 1, or a d is positive or d is bigger than 2 and b d minus 1 is bigger than 1. But in our case, A2 plus A3 is A1. That means our case A2 plus A3 is A1. So this does not hold. So A3 have to be 0 and B2 have to be 1. That means A1 is equal to A2. So B1 is also equal to A3. B1 is also equal to C2. So the graph is Taylor graph. Let gamma be a distance regular graph with diameter 3 and balance k if one of C2 is bigger than half k, or A2 is at least half k2 minus 1, or B2 is bigger than half k3 wholes, then gamma is Taylor graph or bipartite. All those three conditions implies P2, 2, 3 is 0. That is equivalent to P3, 2, 2 is 0. So from the previous proposition, the graph is Taylor or bipartite.
Every Taylor is bipartite, right?
Yes, sir.
Is every Taylor graph bipartite?
No? I'm sorry, I'm listening. Okay. In here, the dotted graph have intersection rate like this. That means A1 is 16, non-zero. So this is not bipartite. So Taylor graph and non-bipartite, then the distance to graph is also Taylor graph. So we are focused on A1 and C2 by dually. And let gamma be a distance regular graph with diameter 3 and balance k if gamma is non-bipartite and not a Taylor graph, then k2 is at least maximum 2b1 and 2C3. Non-bipartite, not Taylor, implies C2 is at most half K and B2 is at most half K3 by lemma, by lemma 2. This implies K2 is bigger than 2B1 and K2 is bigger than 2C3. So K2 is at least maximum 2B1 and 2C3. And here note, B2 is bigger than half K3 is equivalent to K2 is smaller than 2C3. Let gamma be a distance regular graph with diameter D, valence K, and B. If diameter is 3, then the number of vertices is at least 2, 1/3 K, or gamma is bipartite, or K3 is 1. And diameter 3 and A3 is 0, then one of the following false. The number of vertices is at least 3 times K plus 1, or Taylor, or bipartite. Let gamma be a distance regular graph with diameter 2 and valence K and number of vertices, V vertices. If gamma is a totally graph with V is at most 7K, then gamma is the Peterson graph or the pentagon. Let gamma be a distance regular graph with diameter D and valence K. If gamma is a totally graph with K is at most 6 times A1 plus 1 and C2 is at least 2, then gamma is icosahedron or locally Peterson graph. Let gamma be a distance regular graph with diameter at least 3 and valence K. If A1 is at least half K minus 1 and C2 is at least 2, then B2 is smaller than C2. That implies diameter is exactly 3. If gamma is totally graph, then by theorem 6, the graph is icosahedron. And if gamma is non-totally graph, gamma is not a totally graph, then gamma contains a quadrangle. That implies B2 is smaller than C2. Let gamma be a distance regular graph with diameter D and valence K. If D is at least 3, then A1 is at most 2/3 K. Let gamma be a distance regular graph with diameter 3 and eigenvalues K, theta 1, theta 2, theta 3. If A3 is 0, then the following holds. A3 is 0 implies theta 1, theta 2, theta 3 are eigenvalues of this matrix. Then the principal submatrix minus 1, 0, 0, minus 2 of T has eigenvalues minus 1 and minus B2. Then by interlacing, the inequality holds. Let gamma be a distance regular graph with diameter at least 3 and valence K. If A1 is at least half K minus 1, then one of the following holds. Gamma is a line graph. It is already classified by Brower, Bohr, and Taylor. And gamma is Taylor graph. Taylor graph, there are many cases, so we cannot classify this family. And except those things, the graph is finite many. actually 3200 is big number, so we are trying to make this number too short, too small. And the examples that satisfies A1 is at least half k minus 1 and not a line graph. There are Johnson 7 3 and Hard 7 cube. That means this set is not empty. Robbins and Brower showed the following theorem. Let gamma be a distance regular graph with diameter at least 3 without induced 3 clove. Then gamma is one of the icosahedron, a polygon, line graph of Moore graph, the flat graph of regular generalized D-gon of order SS. Then in Taylor's theorem, the without induced 3 clove implies A1 is at least half k minus 1. So in some sense, theorem 10 is a generalization of their theorem. And let gamma be a distance regular graph with diameter 3 and balance k is at least 3. If A2 is 0 and C2 is at least 1/3 k, then gamma is bipartite. And let gamma be a distance regular graph with diameter at least 3 and balance k. If A2 is positive and C2 is at least A2 plus 1, then gamma is Taylor or diameter is 3 and finitely many. Thank you.
Any questions?